Uh, break दिया हो ना दिया हो 10:30 Yes. Good morning, students. Today we'll start a new topic, that is coordinate geometry. The chapters to be covered in coordinate geometry are: the first chapter is points and straight line. Second one is pair of straight lines. Third is circle. Fourth is parabola. Hyperbola. Okay. So so let's start with points and straight line. In Cartesian coordinate system, the system consists of two mutual perpendicular lines. One is parallel to the surface of the earth known as the x-axis, and another one is perpendicular to the surface of the earth known as y-axis. Okay, these two mutual perpendicular lines divide the plane into four regions. Each region is called a quadrant. This is called a first quadrant. Second quadrant. Third quadrant. And this one is fourth quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. Then come to Cartesian coordinate of a point. Let P be a point in the two-dimensional plane. To determine the position of the point P, or to find the coordinates of a point P, we have to draw two perpendiculars from the point P. One perpendicular is drawn from point P upon x-axis. Let M be the foot of the perpendicular. Another one is drawn from P upon y axis. Let n be the foot of the perpendicular. So length ON is known as x coordinate of the point, let it be small x, and length ON is the y coordinate of the point, let it be small y. Then the point P is denoted by the order pair x comma y. The order pair xy are called coordinates of the point. The first component is called x coordinate or abscissa. This is called x coordinate or abscissa. And the second component of the order pair is known as y coordinate or ordinate. Y coordinate or ordinate, right? So x coordinate determines the distance of the point from y axis, and y coordinate of the point determines the distance of the point from x axis. So note it down. X coordinate mod x, distance of the point. If xy be the coordinates of the point P, then mod x is the distance of the point P from y axis. And mod y is the distance of the point P from x axis. Clear? Is it clear to you guys? Is it clear? Barsha, Arnab, point P having coordinate x comma y lies on x axis, then y is equal to 0. If the point lies on y axis, then x is equal to 0. If the point P lies on x axis, then y coordinate is equal to 0. If the point P lies on y axis, then x coordinate is equal to 0. Clear? Quickly note it down. Come to distance formula, distance between two given points. Distance between two given points. Write on the distance between the points. The distance between the points Px1, y1 and Qx2, y2 is given by the distance PQ equals under root plus y2 minus y1 whole square. This is x-axis, xy dash. Your y-axis. This is suppose point P, having coordinate x1, y1, and this is point Q, having coordinate x2, y2. Okay, we want to find the distance PQ. Let us draw two perpendiculars from P and Q upon x-axis. Let M and N be the foot of the perpendicular. And drop another perpendicular from point P upon QN. Let R be the foot of the perpendicular. Since coordinates of the point P are x1, y1, then OM length is x1 and ON length, coordinates of Q are x2, y2. ON length is x2. So MN length is x2 minus x1. Length MN is equal to PR. PR is equal to x2 minus x1. This length is y1. Total length is y2. So this length will be y2 minus y1. So PQR is a right angle triangle using Pythagoras theorem. So in the triangle PQR, PQ square is equal to PR square plus of QR square. The length PR is equal to x2 minus x1. So x2 minus x1 whole square plus of y2 minus y1 whole square. So length PQ is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Length PQ is equal to x2 minus x1 whole square plus y2 minus y1 whole square root over. This is your distance formula, okay? So let us come to solve a couple of rudimentary questions on distance formula. The distance between the points two comma minus 1 and a comma 2 is 15 units, then find the value of A. This is the question, okay? 2 points are given in which an unknown parameter A is there, and the distance between the two given points is given. We have to find out the value of the unknown parameter A. So come to the solution. Let P be the point 2 comma minus 1 and Q be the point A comma 2. Length PQ is equal to 15 units. So this implies under root a minus 2 whole square plus 2 minus of minus 1, 2 plus 1, 3 square is equal to 15. This implies a minus 2 whole square plus 9 is equal to 225. So a minus 2 whole square is equal to 216. A minus 2 is equal to plus or minus root over of 216. A is equal to 2 plus or minus root over of 216. This is the answer. Okay, I hope it is clear to you. Write in the chat box, is it clear? Hello. Okay. Then come to another question. Using distance formula, so that the points P having coordinate A comma B plus C, Q, coordinate B comma C plus A, R, C comma A plus B are collinear. Try to prove it. Using distance formula, so that the points P having coordinate A comma B plus C, Q comma B plus C plus A, R comma C plus A plus B are collinear. Using distance formula, we have to prove that the points PQ are collinear. Collinear means they lie in one straight line. Okay. So it is enough to show that the length of the segment PQ plus segment QR is equal to length PR. So first of all, we have to find out three distances, that is distance between P and Q. Then second one is distance between Q and R. And the third one is distance between P and R. So using distance formula, we can calculate PQ is equal to under root A minus B whole square plus of B plus C minus C plus A, that is B minus A whole square. You know, A minus B whole square is equal to B minus A whole square. This is equal to 2 times A minus B whole square. This is root 2 times A minus B. Okay. Similarly, the distance between Q and R, QR is equal to under root B minus C whole square plus C minus B whole square. This is equal to root 2 times B minus C. And the length PR is equal to root 2 times C minus A, PR plus PQ plus QR, PQ plus QR is equal to root 2 times A minus B plus B minus C is equal to root 2 times A minus C. We can write this one as root 2 times A minus C also. Okay. I hope it is clear to you. Did you understand, guys? Is it clear? Write in the chat box. Anwesan, Arnav, Ashok, Varsha. Okay. Let's move forward to the section formula or division formula. Section formula or division formula. Section formula or division formula, write down. If R x comma y be a point on the line segment joining Px1 y1 and Qx2 y2 such that R divides PQ in the ratio m is to n, first bit internally, second bit externally, then the coordinates of point R are given by x is equal to mx2 plus nx1 upon m plus n, y equals my2 plus ny1 upon m plus n. This is for internal division. For external division, x is equal to mx2 minus nx1 upon m minus n, y equal to my2 minus ny1 upon m minus n. Okay. So, guys, you have to keep in mind if it is given that, yes, new message. Okay. If it is given that the point R divides PQ in the ratio M is to N, then the coordinates of a point P should be taken as x1, y1, and coordinates of point Q should be taken as x2, y2. If it is given point R divides QP in the ratio M is to N, then coordinates of Q should be treated as x1, y1, and coordinates of P x2, y2. Okay. And formula should be used in cross manner. That means left ratio should be multiplied. R divides PQ in the ratio M is to N. So left ratio should be multiplied with right coordinate, and right ratio should be multiplied with left coordinate. mx2 plus nx1 by m plus n. Similar is the case for y coordinate. my2 plus ny1 upon m plus n. In distance formula, so there is no distinction of choosing x1, y1 and x2, y2. But in division formula, you have to check whether the point R divides PQ in the ratio m is to n or QP in the ratio m is to n. If it divides PQ in the ratio m is to n, then the coordinates of P will be taken as x1, y1, and coordinates of Q should be taken as x2, y2. Right? I hope it is clear to you. For external division, the point P will be outside the line segment PQ. This is Px1, y1. This is x2, y2. And this is the point R, which is taken on extended part of line segment PQ. It should be xy. This length, PR length, is m unit, and QR length is n unit. Right? Then come to midpoint formula. Coordinates of point P are x1, y1. Coordinates of point Q are x2, y2. R is the midpoint of PQ. So R divides PQ in the ratio 1:1. Midpoint means R divides PQ in the ratio 1:1. Let x, y be the coordinates of point R. So x is equal to x1 plus x2 upon 2, and y is equal to y1 plus y2 divided by 2. The coordinates of point x are x1 plus x2 divided by 2. Coordinates of point y are y1 plus y2 divided by 2. Clear? Then come to parallelogram test. Parallelogram test. If P x1, y1 Q x2, y2 R x3, y3 and S x4, y4. If P x1, y1 Q x2, y2 R x3, y3 and S x4, y4 be the vertices of a parallelogram, taken in order then x1 plus x3 is equal to x2 plus x4 and y1 plus y3 equals to y2 plus y4. x1 plus x3 is equal to x2 plus x4 and y1 plus y3 equals to y2 plus y4. Quickly note it down. I'll go to the next page. Come to the explanation or proof. PQRS are the vertices of the parallelogram taken in order. This is point P, Q, R, S. Coordinates of point P are x1, y1. Coordinates of point Q are x2, y2. Coordinates of point are x3, y3. And coordinates of point S are x4, y4. It is given. And we have to establish the relation among x1, y1, x2, y2, x3, y3, and x4, y4. You know, diagonals of a parallelogram bisect each other. PR is a diagonal. QS is another diagonal. Let T be the point of intersection of these two diagonals. So diagonals of a parallelogram bisect each other. That means PT is equal to TR and ST is equal to QT. So T is the midpoint of a PR as well as QS. Since T is the midpoint of a PR, so coordinates of T will be x1 plus x3 divided by 2, y1 plus y3 divided by 2. The coordinates of point T. Again, according to the midpoint of QS, the coordinates of point T are x2 plus x4 by 2, comma y2 plus y4 by 2. y2 plus y4 by 2, right? The point is the same point. Same one point should not have more than one pair of coordinates. So x1 plus x3 by 2, x1 plus x3 by 2 is equal to x2 plus x4 by 2 and y1 plus y3 by 2 equal to y2 plus y4 by 2. 2 cancels, these 2 cancels. So x1 plus x3 is equal to x2 plus x4 and y1 plus y3 is equal to y2 plus y4, right? x1 plus x3 is equal to x2 plus x4 and y1 plus y3 is equal to y2 plus y4. I hope it is clear to you. Write in the chat box, is it clear? Subhranshu, Arnav, yes, okay. So write down a question. If P1, 2, Q3, minus 1 are 5, minus 4 and S, X, Y be the vertices of a parallelogram, then find X and Y. Then find X and Y. What is the answer? Coordinates of P are 1, 2. Coordinates of Q are 3, -1. Coordinates of, yes, somebody has sent the answer. Let me check. X is equal to 3, Y is equal to -1. Let me check. And 5, -4, X, Y. So X1 plus X3, that is 1, 1 plus 5, 6 is equal to 3 plus X. This implies X is equal to 3 and 2, 2 plus -2 is equal to -1 plus Y implies Y is equal to -1. Okay, you are correct. Okay, let's move forward. Write down centroid of triangle. Centroid of triangle. Write down medians of a triangle. Medians of a triangle are concurrent. Medians of a triangle are concurrent, and the point of concurrency is called centroid. Medians of a triangle are concurrent, and the point of concurrency is called centroid. So guys, this is the triangle ABC. You know what is median? The line which joins a vertex to the midpoint of the opposite side is called median. Let the midpoint of a BC be D. Then AD is called a median. Similarly, there are three medians. B is another median and CF is another median. These three medians are concurrent, means they pass through same point. Clear? The point of concurrency, that means the point at which all the three medians meet, is known as centroid of the triangle. Centroid of the triangle, and generally it is denoted by capital G. Okay. Another note point: centroid divides the respective medians. Centroid divides the respective medians in the ratio 2:1. Centroid divide the respective medians in the ratio 2:1. That means AG is to GD. AG is to GD is equal to 2:1. Clear? Then come to coordinates of centroid of triangle. Coordinates of centroid of a triangle. Coordinates of centroid of a triangle. Write down this is of a triangle ABC. If AX1, Y1, BX2, Y2, CX3, Y3 be the coordinates of vertices of triangle ABC, then the coordinates of a centroid are coordinates of centroid are x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. Coordinates of centroid are x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. Come to the proof. Let D be the midpoint of BC. So midpoint means it will divide the line segment BC in the ratio 1:1. So by midpoint formula, the coordinates of point D are x2 plus x3 upon 2, comma y2 plus y3 upon 2. Alright. Now join A with D. So G is the centroid. G divides AD in the ratio 2:1. Let coordinates of point G be x, comma y. So by internal division formula, x is equal to, I have already told you the formula in division formula should be used in cross manner. That is, left ratio should be multiplied with right coordinate. 2 into x2 plus x3 upon 2 plus 1 into x1 divided by 2 plus 1, which is equal to x1 plus x2 plus x3 upon 3. Similarly, the y coordinate of the point that is centered will be 2 into y2 plus y3 upon 2 plus 1 into y1 divided by 2 plus 1. This is equal to y1 plus y2 plus y3 upon 3. Okay. Is it clear? Okay. Going to discuss couple of questions on centroid. Question number 1. Find the coordinates of centroid of the triangle whose vertices are find the coordinates of centroid of the triangle whose vertices are 2, -1, 3, 2, and 1, 8. 2, -1, 3, 2, and 1, 8. You can solve this question. Solve it, send me the answer. Two, 3, Subhranshu. Yes, 2, 3 is the right answer. Yes, Pankaj. Pankaj is late join kala ki? Next question, question number 2. If A 1, 2, B 4, 1 be the vertices of a triangle ABC, whose centroid is at 3, 2, then find the coordinates of third vertex C. Then find the coordinates of third vertex C. Okay, this is the question. Try to answer this question. Okay. Let me check the answer. Four answers. 4,6, 4,3. Which one is correct? 2. Let me check. So 1, let the coordinates of vertex C be x comma y. So 1 plus 4 plus x upon 3 is equal to 3. Implies x is equal to 9 minus 5 is equal to 4. Then 2 plus 1 plus y upon 3 is equal to 2. So y is equal to 3. Okay, x is equal to 4 and y is equal to 3. This is the answer. Next question. So rather than the next question, if alpha, beta, gamma are roots of the equation x cube minus 6x square plus 11x minus 6 is equal to 0. If alpha, beta, gamma are roots of the equation x cube minus 6x square plus 11x minus 6 is equal to 0, then find the coordinates of centroid of triangle whose vertices are alpha, 1 upon alpha, beta, 1 upon beta, and gamma, 1 upon gamma. Okay, this is the question. If alpha, beta, gamma are roots of the equation x cube minus 6x square plus 11x minus 6 is equal to 0, then find the coordinates of centroid of the triangle whose vertices are alpha, 1 upon alpha, beta, 1 upon beta, and gamma, 1 upon gamma. This is the question. Okay, try to solve it. What is the answer? Anybody? So, Rubalakshmi, I want the x coordinate in terms of number, not in terms of alpha, beta, gamma. Okay. 2, 2 by 3. Okay, let me check whether it is 2, 2 by 3. So, 2, 11 by 6. So, can you factorize the expression, cubic expression x cube minus 6x square plus 11x minus 6? So, the expression x cube minus 6x square plus 11x minus 6 is equal to x minus 1 into x minus 2 into x minus 3. If you equate it to 0, then either x will be 1 or x is equal to 2 or x is equal to 3. So one of the value will be alpha, second one will be beta. Let alpha is equal to 1, beta is equal to 2, and gamma is equal to 3. You can take alpha is equal to 2 also, or alpha is equal to 3. Okay. So the coordinates of point are 1, 1, 2, 1 by 2, and 3, 1 by 3. We are asked to find out the coordinates of centroid of the triangle. Coordinates of centroid are 1 plus 2 plus 3 by 3, 1 plus 1 by 2 plus 1 by 3 upon 3. This is equal to 6 by 3 is equal to 2. And this LCM will be 6. Yes. 2. Subhalakshmi is correct. 2, 11 by 18. Okay. So write down a note point. So this is the triangle ABC. And G be the centroid of the triangle ABC. Then G with vertices. And then area of triangle GAB is equal to area of triangle GBC is equal to area of triangle GCA. Okay. Area of triangle GAB is equal to area of triangle GBC is equal to area of triangle GCA. Then write down circles connected with triangle. First write down in circle. Write on bisectors of internal bisectors of angles of a triangle are concurrent and the point of concurrency is called incenter. Internal angle bisectors of a triangle are concurrent and the point of concurrency is called incenter. This is suppose triangle ABC. These three bisectors meet at a point. This point is known as incenter. A circle taking incenter as center and the radius is equal to length of the perpendicular drawn from incenter upon any side is called incircle of the triangle. This is and the radius is known as in radius and it is denoted by small r. Okay. Write down coordinates of incenter. Coordinates of incenter. Coordinates of incenter. Write down if x1 y1 bx2 y2 cx3 y3 be the vertices of a triangle ABC if ax1 y1 bx2 y2 cx3 y3 be the vertices of a triangle ABC, then the coordinates of incenter of triangle ABC are ax1 plus bx2 plus cx3 upon a plus b plus c, ay1 plus by2 plus cy3 upon a plus b plus c. ax1 plus bx2 plus cx3 upon a plus b plus c, ay1 plus by2 plus cy3 upon a plus b plus c. This is triangle ABC. The coordinates of vertex A are x1, y1. Coordinates of vertex B are x2, y2. Coordinates of vertex C are x3, y3. Okay. The length of the side opposite to the vertex A is denoted by small a, and the length of the side opposite to the vertex B is denoted by small b. Length of the side opposite to vertex C is denoted by small c. So coordinates of in center of the triangle are ax1 plus bx2 plus cx3 upon a plus b plus c, and y coordinate ay1 plus by2 plus cy3 upon a plus b plus c. So before going to proof, write down a note point, which was a theorem in your earlier school programs. Write down internal angle bisector of a triangle. Internal angle bisector of a triangle internal angle bisector of a triangle divide the opposite side divides the opposite side in the ratio of the sides. Internal angle bisector of a triangle divide the opposite side in the ratio of the sides containing the angle. Okay. If this is the internal angle bisector, means BC at D, so BD is to DC is equal to AB is to AC. Right done. BD is to DC is equal to AB is to AC. BD is to DC is equal to AB is to AC. Okay. Come to the proof. Also, it's government class. ମୁଁ ତ ସାର୍ ଅଛି ଗଭର୍ଣ୍ଣମେଣ୍ଟ କ୍ଲାସରେ ମୁଁ ତ ସରିଲା ବେଳକୁ 11ଟା ହବ। ଓ ହୁଁ ହଁ ଆଜ୍ଞା। This is triangle ABC. Coordinates of vertex A are x1, y1. Coordinates of vertex B are x2, y2. And coordinates of vertex C are x3, y3. Okay. Let AD be the internal angle bisector of the angle BAC. So BD is to DC is equal to AB is to AC. So AB is small c and AC is small b. So D divides BC in the ratio C is to B. D divides BC in the ratio C is to B. So coordinates of D are coordinates of D CX3 plus BX2 upon B plus C, CY3 plus BY2 upon B plus C. Okay. Let the internal angle bisector of angle B meets AD at the point I. Then I is the incenter of the triangle ABC. In the triangle ABD, internal angle bisector of B divides AD at the point I. So DI is to IA is equal to BD is to BA. DI is to IA equals BD is to BA. DI is to IA is equal to BD is to BA. So first of all, we have to calculate the length BD. Length BC is denoted by small a. Length BC is small a. This is B part, and this is C part, and this is B part. So C plus B part corresponds to length A. By unitary method, one part will be A upon B plus C, and the BD is C part. So C part will be equal to AC upon B plus C. So length BD is equal to AC upon B plus C. So DI is to IA. DI is to IA equal to BD is equal to AC upon B plus C is to BA is C. We can cancel C from both the terms. So A upon B plus C is to 1. Or the ratio is A is to B plus C. Okay. The point I divides DA in the ratio A is to B plus C. Point I divides DA. This is D point. This is A point. This is I. I divides DA in the ratio A is to B plus C. Coordinates of A are x1, y1. And what are the coordinates of D? Coordinates of D are CX3 plus BX2 by B plus C, CY3 plus BY2 by B plus C. Okay. I have to create some space here. Okay, by internal division formula, coordinates of I A into AX1 plus B plus C whole into BX2 plus CX3 by B plus C divided by A plus B plus C This is x coordinate. Similarly, y coordinate will be ay1 plus b plus c whole into bx2 plus cx3 upon b plus c whole divided by a plus b plus c. Here b plus c cancels, b plus c cancels. The coordinates of I are ax1 plus bx2 plus cx3 upon a plus b plus c ay1 plus by2 plus cy3 upon a plus b plus c. Okay, this is the proof. I hope it is clear to you. Pankaj, Arnav, Subhanshu, is it clear? Quickly note it down. This is in radius R. So note it down. R is equal to delta upon S, where delta is the area of the triangle delta is the area of the triangle and S is the semi-perimeter of the triangle. And S is the semi-perimeter of the triangle. Okay. Yes, then come to, so write down a question and the coordinates of in center of the triangle whose vertices are 0, 0, 1, 2 and 2, -1. And the coordinates of vertices of triangle di is to ia proof. Okay. Di is to ia. Should I explain it again? Okay, let me explain it again. ABC. This is D. The coordinates of D are Bx2 plus Cx3 upon B plus C and By2 plus Cy3 upon B plus C. Acha, ABD is a triangle. Bisector of angle B meets AD at I. So, internal angle bisector of a triangle divide the opposite side in the ratio of the sides containing the angle. So, DI is to IA is equal to BD is to BA. DI is to IA is equal to BD is to BA. Clear? Well, length AB, DI is to IA is equal to BD is to BA. Is it clear? Write in the chat box. This part is clear. So length BA or AB is C. Length AB is C. Okay. Length AB is C. How to find the length BD? The total length BC is equal to A. Total length BC is equal to A unit. You know, D divides BC in the ratio C is to B. That means this is C part, this is B part. This is C part, this is B part. Total is B plus C part. So B plus C part corresponds to length A. This length BD is equal to C part and length DC is equal to B part. So B plus C part corresponds to length A. Is this clear? Okay. Then unitary method. Apply the unitary method. Apply the unitary method. One part will be equal to, if B plus C part is equal to length A, then one part will be A upon B plus C. We have to find out the length BD. What is BD? BD is C part. So C part will correspond to length AC upon B plus C. Is this clear? Is this clear, Subhranshu? Arnab? Once more, okay. Arnab, total BC length is A unit, of which BD is C part and DC is B part. Total B plus C part corresponds to length A. B plus C part corresponds to length A. One part will be A upon B plus C. C part will be AC upon B plus C. So take another example. Suppose BC length is 20 unit. BC length is 20 unit. BC length is 20 unit. Okay. So BD is 2 part and DC is 3 part. So BD is 2 part and DC is 3 part. Okay. So that means D divides BC in the ratio 2:3. Okay. So 5 part correspond to 20 units. So one part will be 20 by 4, 5 units. So what is BD? BD is 2 parts. So BD will be 2 into 5, that is 10. Oh, this is 5, na? This is 4. Okay, one part will be 4. So 2 part will be 2 for the 8. So if total length is 20 and this part is 2 unit and 2, this is 3 part. So it will be 8 units, it will be 12 units. I hope it is clear to you now. Is it clear? Arnav? Okay. So C part will be AC upon B plus C, that is the length of BD is equal to AC upon B plus C. So DI is to IA is equal to BD is to BA. So DI is to IA is equal to BD is to BA. What is BD? BD is your length AC upon B plus C is to BA is C. You know, you can cancel the common term from both sides of a ratio. So common term is C. You can cancel C from this is A upon B plus C is to 1. So if you multiply both, then by B plus C, it will be A is to B plus C. because 2:3 ratio can be written as 4:6. Okay. I hope it is clear. Now you have to apply only internal division formula to get the answer. Okay, Subhranshu, it is clear. So R is equal to delta upon S. R is the in radius of the triangle. In radius is equal to area of the triangle divided by semi-perimeter of the triangle. You know, sum of the sides of the triangle is perimeter and it is denoted by 2S. 2S is equal to A plus B plus C, that is perimeter of the triangle. And AC is known as AC is equal to A plus B plus C by 2, which is known as semi-perimeter of the triangle. Got it? I hope it is clear. Okay. Okay, then for question okay, find the coordinates of in center of the triangle whose vertices are 0, 0, 1, 2 and 2, minus 1. Try to answer this question. One comma 1/3, Subhranshu? I don't think so. First of all, you have to find the length of the side of the triangle. Okay. This is about vertex A. This is vertex B. This is vertex C. What will be the length AB? Length AB will be √5. What is length BC? Length BC is equal to √10. And what is length AC? AC is also √5. AB √5, BC √10, AC √5. Okay. So 0, 0, 1, 2, and 2, minus 1. This is √5. This is √5. And this is √10. Clear? So √10 into 0, ax1 plus bx2 plus √5, ax1 plus bx2 plus cx3 plus 2 √5 divided by √10 plus √5 plus √5. This is equal to 3 √5 divided by √10 into 0. 3 √5 by, if you take √5 as common, √5 into √2 plus 2. So √5 cancels. X coordinate is 3 upon 2 plus root 2. X coordinate is 3 upon 2 plus root 2. Similarly, you can calculate the Y coordinate. Did you understand? Subhranshu, did you understand where you made a mistake? The incenter is clear, then come to circumcenter. Then come to circumcenter, write down. Okay, circumcenter, write down. Perpendicular bisectors of sides of a triangle are concurrent and the point of concurrency perpendicular bisectors of sides of a triangle are concurrent and the point of concurrency is called circumcenter. And circumcenter of a triangle is equidistant from the vertices of the triangle. Circumcenter is equidistant from the vertices that may or may not lie inside the triangle. Okay, this is circumcenter. This is one of the perpendicular bisector of the sides. This is another perpendicular bisector of the side. This is another perpendicular bisector of the side. Okay, this distance is known as circumradius. Wait, we can draw a circle like this. The circle is called circumcircle. It will be better if you draw the circle first, then inscribe the triangle. You will get a good figure. A, B, C. If OB is the circumcenter, then OA is equal to OB is equal to OC is equal to circumradius, that is R. OA is equal to OB is equal to OC is equal to circumradius, which is equal to R. Clear? Write down coordinates of circumcenter. Although there is a formula to find the coordinates of circumcenter, but we should not use that formula. For the sake of completion, I will write the formula. But you can't use that formula. Okay. Formula is very tedious one. Write down coordinates of circumcenter. If A x1 y1 B x2 y2 C x3 y3 be the vertices of a triangle then coordinates of circumcenter are x1 sin 2a plus x2 sin 2b plus x3 sin 2c upon sin 2a plus sin 2b plus sin 2c, and y coordinate will be y1 sin 2a plus y2 sin 2b plus y3 sin 2c upon sin 2a plus sin 2b plus sin 2c. x1 sin 2a plus x2 sin 2b plus x3 sin 2c upon sin 2a plus sin 2b plus sin 2c, y1 sin 2a plus y2 sin 2b plus y3 sin 2c upon sin 2a plus sin 2b plus sin 2c. Okay. We should not use this formula because to apply this formula, we have to find the angle of the triangle using cosine formula. Then to use the cosine formula, you have to find out the length of the sides of the triangle by using distance formula. So rather it is better to use the concept how to find the coordinates of circumcenter of a triangle. Quickly note it down. This formula is for the sake of completion, but we are not going to apply this formula. What we will apply is the concept. It is triangle ABC. If O is the circumcenter of the triangle, then OA is equal to OB is equal to AC. First of all, consider let x comma y be the coordinates of the circumcenter. So equating OA with OB, that will give you a linear equation in x and y, equation 1. Again, OA is equal to OC, that will give you another equation in x and y. And you know how to deal with linear simultaneous equation in two variables. You know the methods. The methods are substitution, elimination, and cross multiplication. Any one of the methods can be used to get the coordinates x comma y. Did you understand, guys, what I mean to say? Is it clear? Shubhranshu, Arnav, speed ହେଇଯାଉଛି ମୁଁ speed କହିଦଉଛି କି? Shubhranshu, Arnav, okay then. So we'll apply this concept to get the coordinates of in circumcenter of the triangle. Write down a question. Find the coordinates of circumcenter of a triangle whose vertices are two comma one, 3 comma minus 2, and 4 comma 2. Okay, this is the question. Try to solve it. So guys, what is your answer? Okay, okay, okay. Oh. Come to the solution. Coordinates of circumcenter of the triangle 7/2, 1/2. Let me check. This is the triangle ABC. This is vertex A, this is vertex B, and this is vertex C. Coordinates of vertex A are 2, 1. Coordinates of vertex B 3, -2. And coordinates of vertex C are 4, 2. Okay. Let x, y be the coordinates of circumcenter. Let it be P. So P is the circumcenter. That means length PA is equal to PB. To find P and PB, we need distance formula. You know there is square root symbol in distance formula. So better to take the square of both sides. So PA square is equal to PB square. Okay. This implies x -2 whole square plus y -1 whole square is equal to what is PB? X -3 whole square plus of y +2 whole square So this implies x square minus 4x plus 4 plus y square minus 2y plus 1 x square minus 6x plus 9 y square plus 4y plus 4. Okay. X square cancels, y square cancels from both sides. Taking all the term into right hand side, we'll have left hand side. You will get it will be 2x minus 6y, 4 plus 1 5, 9 plus 4 13. So minus 8 equals to 0, or x minus 3y minus 4 is equal to 0. Let it be equation number 1. Again, similarly equating PA with PP, PC. Again, PA is equal to PC. सर जी अभी गवर्नमेंट क्लास में हूँ, क्लास खत्म होने के बाद आपको कॉल करूँ. अभी गवर्नमेंट का क्लास में हूँ. So again, PA is equal to PC. This implies PA square equals to PC square. PA square is equal to PC square. This implies, what is PA square? X minus 2 whole square plus y minus 3 whole, y minus 1 whole square is equal to PC square. PC is x minus 4 whole square plus y minus 2 whole square. Yes. So this implies x square minus 4x plus 4 plus y square minus 2y plus 1 is equal to x square minus 8x plus 16 plus y square minus 4y plus 4. So x square, y square cancelled. Taking all the terms into left hand side. Create a space here. So 4x. Taking all the terms into left hand side, 4x plus 2y, 4 cancels, minus 15 is equal to 0. This is equation number 2. And equation 1 is x minus 3y minus 4 is equal to 0. This is equation 1. On solving these two equations, we have to find out the value of x and y. X is equal to, apply cross multiplication formula. X is equal to b1 c2, that is minus 8, minus b1 c2 minus b2 c1. b2 c1 is minus 45 upon a1 b2 minus 12 minus 2. So minus 53 upon minus 14. This is equal to 53 upon 14. Okay. Similarly, we'll get the value of y. Y is equal to c1a2 minus 15 minus c2a1 plus 16 divided by minus 2, 12 minus 2. This is equal to minus 1 upon 14. This is the answer. Clear? Shubhranshu. Then write down a note point. Manu, ମୁଁ ଗଭର୍ଣ୍ଣମେଣ୍ଟ ଆସିଥିଲି କହୁନାହାନ୍ତି କି କହିଲେ ଅରୁଣ ବା କଣ ହେଇଯାଇଛି write down a note point the note point is in a right angle triangle midpoint of the hypotenuse. Yes, PB is equal to PC. So you will get the same answer. Okay. Shubhranshu. So write down the note point in a right angle triangle. Midpoint of the hypotenuse is the circumcenter. In a right angle triangle, midpoint of the hypotenuse is the circumcenter. This is A, this is B, this is C, this is called circumcenter, midpoint. So if this is P, PA is equal to PB is equal to PC. PA is equal to PB is equal to PC. Okay, because the angle in a semicircle is a right angle, and this one will be the diameter of the circle, and midpoint is center of the circle. Okay, then circumcenter by observation. Clear? Suppose this is vertex A, coordinates of vertex are 3, 4. Coordinates of vertex B are 5 cos theta, 5 sin theta. Coordinates of vertex C are 5 sin theta, 5 cos theta. So, Subhranshu, this distance, so distance from origin of the point 3, 4 is 5 unit. Distance from origin of this point is 5 unit. Distance of this point from origin is 5 unit. So origin 0, 0 is the circumcenter of the triangle. Okay. So we should write it in the form of a node point. The coordinates of circumcenter of a triangle whose vertices are AB and quickly note it down. Write another note point. Circumcenter of a triangle may or may not lie inside the triangle. circumcenter of a triangle may or may not lie inside the triangle. Okay, second note point. Circumradius R is equal to ABC upon 4 delta. Circumradius R is equal to ABC upon 4 delta. ABC length of the sides of the triangle, delta is the area of the triangle. And the skin radius R is equal to delta upon S. Skin radius R is equal to delta upon S. Circumradius R is equal to ABC upon 4 delta. Clear? Then come to orthocenter. Orthocenter. Altitudes of a triangle are concurrent and the point of concurrency R is the circumradius. So R is the circumradius. Altitudes of a triangle are concurrent and the point of concurrency is called circumcenter. Altitudes of a triangle are concurrent and the point of concurrency is called circumcenter. Oh, sorry. It's called, orthocenter. Yes. Write down coordinates of orthocenter. ये फॉर्मूला खाली पे लिखिया पे लिखिया किंतु कोई यूज करियानी कैलकुलेशन मेरे को बहुत टाइम लगे. We will use another method to find the circumcenter. If ax1 y1, bx2 y2, cx3 y3 be the vertices of a triangle ABC, then the coordinates of its orthocenter are x1 tan A plus x2 tan B plus x3 tan C upon tan A plus tan B plus tan C, comma x1 y1 tan A plus y2 tan B plus y3 tan C upon tan A plus tan B plus tan C. Okay. We will not use this formula to calculate the orthocenter of the triangle, rather we will use the concept, that is slope of this one and slope of this one is equal to -1. Okay. After teaching you the slope concept, I will teach you how to find the coordinates of orthocenter of the triangle, right? So write down a note point. In a right angle triangle, orthocenter is the right angled vertex. So BC is a right angle triangle, right angle at B. So B is the orthocenter. Write down another note point. Orthocenter may or may not lie inside the triangle. Orthocenter may or may not lie inside the triangle. Another note point, the image of orthocenter about any side of the triangle lie on circumcircle of the triangle. The image of orthocenter of a triangle about any side of triangle lie on lies. Let me explain it to the figure. The triangle ABC. This circle is the circumcircle of the triangle ABC. If you reflect let H be the orthocenter. If you reflect the orthocenter on side BC, its mirror will be on circumcircle H dash. Or if you want to reflect it along AC, here will be H dash. Okay. So image of orthocenter on any side of the triangle lies on circle of the triangle. Quickly note it down. Subhranshu, is it clear? Then write down very important formula, ONGC formula, ONGC, Oil and Natural Gas Corporation of India. ONGC. O stands for orthocenter. N for 9-point center. G for centroid. C for circumcenter. Okay. O for orthocenter. N for 9-point center. G for centroid. C for circumcenter. Write down ONGC formula. Is very important from JEE point of view. Write down in a triangle, orthocenter nine-point center in a triangle, orthocenter, 9-point center, centroid, and circumcenter are collinear and centroid divides the join of orthocenter and circumcenter in the ratio 2:1. In a triangle, orthocenter, 9-point center, centroid and circumcenter are collinear, and centroid divide the join of orthocenter and circumcenter in the ratio 2:1. OG is to GC is equal to 2:1. At a 9-point center is the midpoint of 9-point center is the midpoint of 9-point center is the midpoint of orthocenter and circumcenter. Quickly note it down. Write down an important formula based on ONGC formula. If A x1 y1 B x2 y2 Cx3y3 be the vertices of a triangle if ax1y1, bx2y2, cx3y3 be the vertices of a triangle whose circumcenter at origin, that is 0, 0, then the coordinates of its orthocenter are x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. Okay, quickly note it down. Sorry. Coordinates of its orthocenter are x1 plus x2 plus x3, y1 plus y2 plus y3. Andra, 6-7 ଜଣ ଅଛନ୍ତି ଆଉ 5 ମିନିଟ୍ ପରେ 5 ମିନିଟ୍ ପରେ କରିଦେବା। Okay, come to prove this. x1, y1, x2, y2, x3, y3. The coordinates of centroid are x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. Okay, and it is given that coordinates of circumcenter is at 0, 0. This is orthocenter. Let the coordinates of orthocenter be x, y. This is centroid G. Coordinates of G are x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, and circumcenter at 0, 0. So according to ONG's formula, centroid G divides OC, join of orthocenter and circumcenter in the ratio 2:1. So x1 plus x2 plus x3 by 3 is equal to 2 into 0 plus 1 into x upon 2 plus 1. This is equal to x by 3. So 3 cancels. X is equal to x1 plus x2 plus x3. Similarly, y1 plus y2 plus y3 by 3 is equal to 2 into 0 plus 1 into y upon 2 plus 1. 2 plus 1, 3 cancels. So y by 3. So y is equal to y1 plus y2 plus y3. So coordinates of orthocenter are x1 plus x2 plus x3, comma y1 plus y2 plus y3. Okay, guys, quickly note it down. So guys, your points portion is over. In the next schedule, we will discuss area of the triangle, then slope, angle between two lines, condition for parallelism, condition for perpendicularity, then equation of straight line in different forms. Okay, all these things will be discussed in the next session. So today's session is over. I hope it is clear to you what I discussed today, Subhanshu. Subhanshu or Subhranshu? Satyajit, Subhranshu, I hope it is clear to you. You are from which high secondary school? Subhranshu, you are from which high secondary school? Oh, Subhanshu, not Subhranshu. You are from which higher secondary school? From GSCR. GSCR means where it is? Okay, guys, your session is over.